This is a lecture for Math 60, Section 4.1. This is on systems of equations and graphing. So far in this class, we've been solving equations by finding ordered pairs, like when we would set up a table and plug in some points and kick out some ordered pairs. And then we would take those ordered pairs and we would graph all those points, connect them up, and hopefully we got a line. The lines that we graphed represented all of the possible solutions for that equation. Now we're going to continue to graph the equations. We're going to continue to graph the lines, but this time we're going to be working on two equations on the same grid. And we did that once before, like if we didn't want to have a separate grid for every single equation. But this is going to mean something a little bit different this time. Whenever you have two or more equations that you're working with, it's referred to as a system of equations. It means nothing more than that. So if those words are used in directions on a test or in your homework, you should know what that means. A system of equations, nothing more than two or more equations. And there's usually something going on between the two. When you have a system like this guy, there are three things that are possible. They're either going to cross each other, the lines, once you graph them, they're going to cross each other, and if they're truly lines, they're only going to connect at one point. They're not going to cross each other at all, meaning that they're going to end up being parallel, and if they're parallel, they have nothing in common. Or one's going to be right smack dab on top of the other, meaning they're basically the same line, and they'll have infinitely many solutions. Out of your text, there's a nice representation of those three things. A solution of a system of two equations and two variables is an ordered pair of numbers that makes both equations true. The numbers in the ordered pair correspond to the variables in alphabetical order. So let's see what that means. So in this case, we've got these two equations that were, these guys down here, that were plotted, and you can see they're crossing each other, and they cross at exactly one point. And the variables in the equations are x and y. So if I knew what the ordered pair was here, and it looks like it's going to be 1, 2, then that's the only solution that both of these guys have in common, this being the x value, this being the y value. This system, then, is considered to be consistent. That's a term that's applied to that, and it has exactly one solution. Neither equation is a multiple of each other. Neither equation is dependent on each other, and so these guys are referred to as independent. So when they intersect at one point, they're considered consistent and independent. On this next guy, you can see that these two equations, when they're graphed, they end up with two lines that are parallel to each other. They have nothing in common. And we know that they're parallel. Confirmation is because the slope here, -3, is the same as the slope over here. We knew before from chapter 3 that if two lines are parallel, then their slopes are identical. Because they have nothing in common, we say that they are inconsistent and they have no common solution. And since neither equation is a multiple of the other, we say that they're independent. And finally, on this last guy, you can see that you only see one line here, but the reason you only see one line is because both the lines are on top of each other. And if you look closely at this equation right here, if I were to take this guy and multiply it by a -4, I would end up with this guy. So this guy right here is nothing more than a multiple of this guy. So they're basically the same graph, the same line, and they're considered to be consistent. So the first two inconsistent, this guy consistent, and they have infinitely number of solutions in common. Well, they're right on top of each other. They're the same line, and since one equation is nothing more than a multiple of the other, we say that they are dependent. That's all there is to say on this, and your homework is on the following page, and I hope that was a good introduction for you.